Rahim. I am Dr. Farah Asad Mansouri. I will be talking about systematic review and meta-analyses and explain to you some of the basic learning regarding this topic. So the learning outcomes for this session is that you should know that what is the hierarchy of the types of studies used in the clinical research, because there are different designs. So we'll see that what is more important. And then we will specifically describe and learn about the design and uses of the systematic review and meta-analyses. This topic is important because you are also exposed to your PE, P2, and you are working on it. So this review, the systematic review, will help you in actually designing and carrying out your review article in the PAP2. So now this is, are you able to see the slide 3 now?
Yes.
Yes, doctor.
Okay, okay. So this is the pyramid which shows that which are the most important or the highest evidence of clinical research is coming from which study articles. So we can see that the topmost evidence is of the systematic reviews with meta-analyses. After this is the randomized controlled trials, then the cohort studies, then case control studies, case series, case reports, experts' opinions and editorials, animal research, or we call it fundamental trials, or in vitro trials. So this is actually the hierarchy of evidence. Whenever you are looking for some article, some research article, you will first look for its design. If it is a case control study, sorry, I must use the. Okay. So you must know that if it is a case control study, so that should certainly come to your mind that it is of less, the grade of evidence is lesser as compared to other. So the highest evidence, if you are finding some systematic review on this, on your search topic, that means this is the highest evidence of the clinical research if it is published as a systematic review with meta-analyses. And similarly, if it is a randomized control trial, though it is a trial, but it is less, carrying lesser evidence as compared to that of the systematic review. So for your better understanding, you must remember these hierarchy of evidence in clinical research. The base is the least important. The highest, the tip is the most important or most significant. So then you should know that what is a systematic review. Oh, I think I have not opened up the, yeah, okay. Yeah, systematic review is actually the overview, or it is the combination of combining the more than one particular research studies in it. So combination of more than one clinical studies is published as systematic review. As the name says, it's a review article. It's a type of an article which we published as a research article. So it is a review, but it is a systematic review because it is carried out in certain by carrying out certain systematic methods and applying a meta-analyses in some of the research topics. Sometimes we don't apply meta-analyses. These are only without meta-analyses, but since we take some systematic methods, so we call it systematic review. Now, what is meta-analysis? What meta-analysis is a statistical method which actually summarize all the studies and then combine the results, these studies. So because if suppose systematic review is talking about 10 different studies, for example, we are not sure that what is the survival in breast cancer. Some studies are saying that the survival is more than 2 times in stage 3. Some are saying that it is less. So then we combine the results and apply the meta-analyses, and it will give us one single quantitative result, and that is known as the pooled result or the overall effect estimate. So the result which we rely out of the meta-analyses is in terms of the pooled effect or overall effect estimate. So I hope I made it clear. Systematic review is a type of a research article which is carried out by combining more than one research studies. And mostly these research studies are randomized clinical trials. But systematic review can be carried out of the case control studies. Systematic review can be carried out of the cohort studies. But the most important one is the systematic review of the clinical trials, because mostly we are hanging around that which treatment, which option is to be preferred. So this is actually can be carried out by performing the systematic review of randomized controlled trials and applying the meta-analyses. Meta-analysis is a quantitative analysis, and it has to be applied by different methods. We see shortly that how. So if you have to name that, what type of article is it? So you can just by seeing that if they have taken more than one studies and taking the summary results of those studies and combining it, then this is a systematic review. And if they are applying certain statistical method in it, then that would be a meta-analysis. But for all practical purposes, some systematic reviews are done without meta-analyses, and some are done with meta-analyses. But there is no, usually we apply meta-analyses in a systematic review article. So this is a bit illustration that if you are carrying out if you are selecting some 4 studies and trying to combine the results of those 4 RCTs, randomized controlled trials, that means we are combining the results that can be without meta-analyses, but in the form of systematic review. But that can be also if you apply the statistical analyses, that is meta-analyses, then again we are combining the results, and this is known as, this is published as systematic review. So I hope you understand this difference with meta-analyses and without meta-analyses. that basically there are sometimes we don't get the enough studies uh, with the accurate results or the required results in these RCTs in order to combine their results. But if the results are present in a sufficient acceptable way, then we can apply the meta-analysis, and then in that way we combine the results. Otherwise, we just summarize the average results of those studies without meta-analysis and publish it as a systematic review. So systematic review is a type of article, is a type of manuscript which is carried out by combining different studies, more than one studies. There's no definite number of studies which are to be included. It can be 2 studies, it can be 6 studies, it can be 10 studies, it can be 20, 40 studies. But usually we see that we don't get quite big number of the included studies, and that is actually that we have to be cautious in the selection of the studies and systematic review. We shortly see that how do we select the studies in systematic review. So I hope I made myself clear that these systematic reviews are type of the article which actually combine the results of different studies. And ideally, we have to take the RCTs for the combination of the studies, for the combination of the results. But it can be other studies, that is case control cohort, or it can be a combination. If you are having, suppose 10 studies in the systematic reviews, few are RCTs, few are case control, few are cohort studies, and then you apply or may not apply the meta-analysis and then combine those results and publish it as systematic review. Up till now, you have, I think, thoroughly covered your experimental design, case control, and cohort. So this is the topmost evidence systematic review in the clinical research. So how this is an illustration that systematic review actually applies the synthesis. That is, it provides an overview of a specific topic or a specific research question by combining all of the high quality research evidence, which is relevant to the particular issue. I give you an example. You all know HRT is there, that is hormonal replacement therapy, one form of the treatment given to the post-menopausal women in order to reduce their post-menopausal symptoms. But in the year 2000 millennium, this was known as the millennium trial, where the systematic review was done because some of the RCTs were saying that hormones are good. Hormones are good to prevent these post-menopausal symptoms. But some were saying that the harm is more than the benefit. So the clinical practice was really not deciding that where to go, whether to prescribe hormones for these post-menopausal women or not, because the harms were reported more in some of the randomized control trials, and in some of the randomized control trials, benefits were reported more. So it was more of the need to carry out this systematic review. So why systematic reviews are carried out? When there is controversy in the results of the randomized control trial, or when there is controversy in the results of cohort studies, or when there is controversy in the results of case control study. As you all know that case control and cohort are and this RCTs are the analytical study designs. They are carried out in order to see the association of the therapy with the outcome, association of the risk factor with the disease. So any associations are seen, are actually established out of those studies. So whenever there's controversy in the association of therapy for that particular disease, or when there's controversy, benefit to harm for that particular drug, then we carry out this systematic review. Have I made myself clear regarding the use of systematic review?
Yes, Doctor.
Yes.
Okay. So that is why a systematic review is a formal, systematic, and structured approach to review all the relevant literature on a particular topic. We gather the information, evaluate it, and then we synthesize the evidence. So then synthesis is done by application of the meta-analyses. In contrast to systematic review, there are narrative reviews, which are actually part of your PEP2, where how the narrative reviews are different from systematic review. In systematic review, we select a very specific objective, while in narrative review, your objective may be a broader one, and there's no there is more of a theoretical explanation of the problem rather than some practical or the results based. So narrative reviews are the publications that describe and discuss the state of specific topic from a theoretical and contextual point of view. So they are not carried out through some systematic methods, and we, in order to identify or assess or synthesize the information. That means you do a literature search, but you don't carry out certain that which studies will be included, which not be included, which objectives are to be there during which time period. It is only suppose you are carrying out a narrative review on suppose management of stroke in cardiovascular disease. So it's a broader topic. You just take out the evidence and then describe it, that what is a stroke, what is the prevalence of stroke in cardiovascular disease, how it is managed, how it is the complications are reported. So it is covering horizontally so many areas in that topic, and this is all theoretical. While in systematic review, we carry out certain certain systems, certain methodology in order to give it a form of systematic review, because we select the studies in a proper way, we extract the information, and then we analyze it by meta-analyses and then reach to some conclusion. So in the narrative review, there's no methodology section. You just identify your objective, and then you do a literature search, and then give a theoretical description of that topic or that objective. Then we can see that this is actually the types of different reviews, because there are original articles and there are review articles. So systematic review is a review article, and it carries the highest evidence, while your narrative review is carrying the lower evidence. Then scoping review is also there. It is also carrying out so many areas in that clinical topic. And then there is some rapid reviews, or they are known as, they are not carried out through certain systematic methods. So they are known as the rapid reviews without giving any specific attention to the articles, type of the articles, the publication date of the article. So this is usually carried out within a month or whatever is being published on that topic. So that is known as the rapid review. While systematic review might take 3 to 6 months to collect the data, to organize the methods, to extract the information, and then apply the meta-analysis. So it's a long process, systematic review, but with higher evidence. Then meta-analysis, it is actually, as mentioned earlier, it is the combination of the data, statistical technique for combining the data or pooling the data from more than one studies, from several studies. Because if some study is giving the outcome for in one way, that is in the positive direction, other studies may be giving the negative readings for the same outcome. As I mentioned about the hormone replacement therapy, some were giving that it is very good in preventing the menopausal, postmenopausal symptoms, but with a good effect. But some studies were giving that because of the increased harm, more side effects, it is not good in giving this hormonal therapy for the postmenopausal women. So this meta-analysis actually combine that data and pull the data from other studies. Now the quantitative approach, this is also, considered as a quantitative approach, because systematic reviews are done sometimes for qualitative data. So there we cannot apply this meta-analysis. I give you the example of qualitative approach that suppose we want to see that there's not enough data regarding the injury management and the road traffic accidents. So we can just describe here and there so many injuries have been reported in the road traffic, and some were severe, some were less severe. So it is not in a quantitative way. So that is a qualitative, and there we cannot apply the meta-analysis. Meta-analysis is only a quantitative approach for the combination of the results to reach to some conclusion. That means either we are looking for the association, strength of the association in the form of odds ratio or relative risk, or in the form of some mean effect, that is a reduction in the survival rate, or similarly some rates or some specific quantities, if they are looked for or combined for, then that is through the means of meta-analysis. So quantitative always refers to numbers. If it is not numbers, the objective of the systematic review, then we won't apply meta-analysis in it. So systematic is more for methodological combining, that means putting together, and then whatever previously done. So this is actually systematic review and meta-analysis is a type of secondary research. It is not a primary or original research. We take the information from already carried out research. So this is how, and then we conclude some new findings in it. Then there are certain steps in the meta-analyses, or we can say steps in the systematic review. That is, we identify the studies based on PICO. That is, we identify PICO is the acronym for P is for patient or population, I is for intervention, C is for comparison, and O is for the outcome. So we should know that if we are identifying some studies for which people, for which patient, that means, as I mentioned you, the example of hormonal replacement therapy for postmenopausal women. So what is the patient or population in that systematic review? The postmenopausal women. What is the intervention for this? That is hormonal replacement therapy. And what is the comparison in it? That is whether using hormones or not using hormones. And the outcome is the benefit versus harm. So that is how we call that PICO should be there in the objective of the systematic review, or in the title of the systematic review. And based on this PICO, we actually identify or select the studies from literature search. So that is how we go about it. Then we see that which studies are eligible to be included or to be excluded. That is, study selection is the next step in it. First is the identification of the study, then the eligibility. Suppose when you go for the identification of the study for that one topic, you may find out thousands of articles in it. But then you apply the eligibility of the study, that during which time period, which language you are going to select, whether you are going to select only full text articles. So that actually gives your inclusion criteria. Then within your inclusion, suppose you find out 1,000 articles on this topic of hormone replacement therapy for postmenopausal women. So out of those 1,000 articles, you will exclude those ones which are duplicated or maybe irrelevant. I mean, they have talked about some other outcome, not the outcome of benefit and versus harm, or they have not been comparing with some other therapy or placebo, so they will be excluded. So inclusion is always based on to the objectives of your systematic review. That is, so there'll be quite many articles, but then you have to exclude it for the duplication. That means you are using three or four browsers for the literature review. So the same articles may be published in different search engines. So you have to be careful in selection of your studies. Then once our sample is identified, that whether there are 10 studies or 20 studies, those to be included, then we have to extract the data from those studies, and this is known as the data extraction step. In the data extraction, we actually find out that which year of the study we make a table on, and then we see we've built a form regarding the data extraction. And then we enter the information regarding each study. If there are 10 study, 1, 2, 3, 4, 5, which year of the study? The second thing is the year of the study. Third thing is the sample size in that study. Fourth thing may be where that study, location of that research, and then maybe the intervention, the outcome, so on. Their primary results, secondary results. So that is how we make a form for all those studies outcome findings. Then we have to apply the statistical analysis for the analyzing the data. And this statistical analysis can be applied either by putting the model of fixed effect or the random effect model. This is a high level of understanding, but you must know that after data extraction, then only we apply meta-analysis. If in your data extraction, you find that it is all qualitative outcomes, so, or in the PICO even, if you find out your outcome is qualitative, then there's no need to apply meta-analysis, because meta-analysis is only considered when it is a quantitative outcome. So the forest plot are the actually ultimate representation, ultimate graphical representation of our meta-analysis. This is known as the forest plot, and it is from, we'll see the next slide, which is from a systematic review of RCTs, which assess the effect of giving corticosteroids to the women who were going to undergo preterm delivery. So here's this is a shape of the forest plot. We call it forest plot because so many studies are clumped together. So much of the information is there, so it's like a forest, right? So that is why it is known as the forest plot. So we can see the studies are listed here on the left side. Then their results in the form of odds ratio is here, and fixed effect model is applied, so that is written as fixed. Then weightage of the study is given here. Weight of the study is given according to the sample size, and we don't have to calculate it. Actually, the software do it for us. So there are so many softwares available to make these forest plot and apply the meta-analysis. And so important to know is that in the meta-analysis, the outcome variables can be your binary data or can be your continuous data. I hope you understand the difference well in the binary data. Binary data is in the form of yes, no, present, absent, and continuous data is in the form of some quantity which can be broken into fractions. So binary data is usually an event rate. That means happening or not happening, improving or not, success or fail. So regarding the treatment, and usually it is in the form of odds ratio or the risk ratio. So, so odds ratio, if it is more than 1, then we say that it is the treatment or the outcome occurred more in the intervention group. If it is less than 1, that means outcome is more in the outcome is less in the intervention group. And if it is 1, that means there is no difference in between the two groups, that is the control group and the intervention group. Intervention group is the one which is given the experimental drug or treatment. So, and the continuous, this was about binary data. Now about the continuous data, it is in the form of mean difference, because it is, we look for that in the meta-analysis, that what is the weighted mean difference and when the units of measurements are the same. Or it can be the standardized mean difference when the units of measurements are different. So it is, here it is seen as the treatment, cognitive behavioral therapy with that of the control. 3 different studies. The mean is this because you can see here that the results are given in the form of mean and standard deviation by these studies. So that is how we apply the meta-analyses for this mean difference. And then we find out this that all these studies are giving favoring the CBT, that is cognitive behavioral therapy. So this black diamond is actually the pooled effect by combining the results or by applying the meta-analyses. These green squares are the individual results of these studies. So it says that yes, it is good that it is on the this CBT is beneficial and as a treatment. So then outcome variables and the meta-analyses, again, if there's no difference, then the mean difference is 0. That is, it is lying on the, I show you here, it will be on the midline, that is 0. So if there is no difference. But if it is on either side, that is, so that is known as the line of no effect. And a negative value means the outcome favors treatment, while a positive value means outcome favors control. That means on the right side, it is the control. On the left side, it is. So we say that if the results are going on this side for the intervention, they are favoring the treatment. If they are going happened this black diamond, if it was seen on the right side, that means we could say that it is favoring control. CBT is of no importance, right? So another forest plot. This forest plot is again of the risk ratio, where actually we are finding the results are given in the form of binary data. So you can see that there are 6 studies, and this is the line of no effect. So it is favoring the experiment because the black diamond is on the left side. You can see the individual study by blue squares, the risk ratio. That is, so the intervention is given here, the control is compared, and the risk ratio is calculated. Weight of the study is given according to the sample size, and then we see whether if this black diamond is on the left side of the line of no effect, that means it is favoring treatment. If it is on the right side, that means it favors control. So let's see the next slide. This is here again a forest plot for another example, and each and every analyses indicators mentioned here. This is left side is about the study, different studies. Here 3 studies are selected, and this is actually in the title, the detail of the reviews given, that supplementation with M in condition comparison, supplementation M versus placebo, the outcome is adverse effects. So then this N is actually the total number of in the group, and small n is the number in the group with the outcome. And in the control group also. The small n is for the number of the sample with the outcome, and big N is for the total number in the groups. This relative risk is the fixed, because you can see that the statistician, when he applied this, used the software for the meta-analysis. It has already taken up as the fixed effect model. And you don't have to really now at this level have to understand that when to apply fixed, when to apply random effect. But these are the two effect models which can be applied, which will be later on in your postgrad you may learn. And weight is the influence of studies on overall meta-analysis based on to the samples included in those studies. And this is the outcome effect measures, relative risk. And what is this? This, as we saw that this black diamond, this diamond shape is actually the pooled effect or the overall effect. And in this example, you can see one study is on the intervention side, favoring intervention. The other one is neutral because it is on the line of no effect. The other study, third study C, is on the right side, that it is favoring control. But while when we pulled up the results, it is again favoring the intervention to some extent. And in the, this is actually shows the heterogeneity of test for heterogeneity for the studies. That is whether the studies are heterogeneous or not. And this is actually the p-value, that whether this heterogeneity is significant or not. So if it is less than 0.05, it is significant. If it is not, that indicates no statistical significance. So this I square is important in order to see heterogeneity. And the figures given in the brackets is actually the confidence interval we see in the next slide. And this is again the same that in this example, 6 studies are selected, and weight of the study we have already understood. The risk ratio when it is binary data. If it is a continuous data, then mean difference or standardized mean difference would have been taken. Now this is, this is here, the width of this line actually tells you about the confidence interval. What is confidence interval? That is an estimate for the surety of your results. The bigger this confidence interval is, less surety. The concise is more sure. So you can see in this study, the confidence interval is less in study 6, while in study 5, the confidence interval is very wide. So that gives less surety. Now, here in this slide, this forest plot highlighting the total effect, this diamond, that all the weighted effects are done, and then the risk ratio is carried out. So it is said that experiment or the intervention is beneficial with 0.6. But you can see that there were different findings in different studies. But the pooled effect favors experiment. In this slide, again, the details are given for the author name, for the year it's published. So whenever we carry out systematic review, our software asks for it, and we actually give the first name of the author because there can be more than one authors in that article. So it is actually the name of the first author is there and the date of the publication. And then it is for the mean, uh, uh, for the weighted mean difference. And you can see there are so many studies in it. Almost 17 studies are there. And this forest is more dense, more, uh, I mean, gathered together. So the weightage of the each article is given here, and then weighted mean by applying the fixed effect model is calculated. And here in the diamond shape, we can see that this is the pooled effect. So you can find out that there were different mean in different studies. But after applying the fixed effect, the pooled mean is minus 1.05 with this confidence interval given in the bracket. Then we see, this is again that names of the authors, for names of the first authors here, favor, no favor, it is again mentioning the same thing which we have already done. Then what are the statistics relevant to the meta-analysis? This is again sample and population. So what is coming out of total population is only a sample. So sample allows us to make the inference regarding the population. And population can be anything. It can be individuals or it can be objects. This you have already probably covered. The confidence intervals we know is indicating the precision of the study. That is, it estimates whether the true mean of the population is captured or not. If there are negative values, 0 is captured. That means it is this is not carrying the true mean, and that is a not a significant confidence interval for means. And for the odds ratio and relative risk confidence interval, if it is capturing 1, that means it is not a significant one. Either it has to be on the positive side or it has to be on the negative side, that is above 1 or less than 1, in order to be significant. So then this we have done as so mostly it is 95% of the confidence interval that is to be used. And but for more sensitive studies, we can select the 99%. This is all on the software of your whatever software you are using for the statistical analysis. So this tells you about the significance, then the size of the confidence interval, as we seen by the lines of the forest plot. If it is narrow, then it is more accurate. That means the line is to be shorter to be more accurate. And so we can say that if the confidence interval is small, that means the sample is close to the mean of the population. That is, mean value of the sample is close to the mean of the population, and it is more reliable estimate. Because if we increase the sample size, that may yield narrow confidence interval, will bring more precision in it. And if we reduce the variability in the sample, that will again narrow the confidence interval. And a large confidence interval results, larger is the broader one. So but it can be, having the true mean if the null values are not included in it. The type of bias in systematic review is actually the publication bias, because if many articles you have missed to be included, that means you are going to introduce publication bias. It can be due to the language bias, it can be due to the citation bias. But overall, we call it as the publication bias. And this can be seen that we have not included, maybe some of the topics are best studied in Chinese, but we are including only English language. So that means we are introducing a publication bias. So overall, it's a publication bias, but it can be a citation bias, because only those articles are cited which have got the positive results or significant results. So negative findings are not being cited or not being reported. So that's why a publication bias is there, maybe because of the language, maybe because of the citation. So yeah, because of the citation, the significant studies are published more and negative studies are not published. So how can we diagnose that whether the publication bias is there or not? That is by means of the funnel plot. So this is also known as the drawer effect. Negative studies. Publication bias is also known as the drawer bias, because whatever we get positive is included. Now, what is funnel plot? Funnel plot is actually the plot which helps us in diagnosing whether the publication bias is there or not. You can see it is like a funnel. It is actually the midline and the treatment working, treatment not working. So that means all those articles which have approved for the positive treatment, they are more, and for the treatment not working are only one here. So this is actually asymmetrical funnel plot. So that means publication bias is there. Here is an example of the symmetrical, that is all those giving the treatment positive is almost equal to that of the treatment negative, the same. So there has to be a equal distribution of this type of the studies in order to avoid the publication bias. So this is how it is asymmetry in the graph or in the funnel plot, highlighting that if you are getting such type of the funnel plot, that means publication bias is there in it. Then how can you find out the systematic reviews? This is, you can search through any database, Medline or PubMed or any other like Science Direct or any other, but the specific one is the Cochrane database of systematic review. This is the website for it, and the its developer was Archie Cochrane, and he actually introduced, he started this Cochrane collaboration. And systematic reviews are more in use in the after the year 1980, but before that, some of the systematic reviews without meta-analyses were still in use. So reviews included in this Cochrane database must adhere to it says that it has to have certain specified protocol, and where every stage of the review is to be made explicit. And then standardized protocol includes objective search strategies, a selection of the studies, a selection of the data analysis procedure. And so that's why this database is the strongest one, Cochrane collaboration. the title of the systematic reviews to be registered. The protocol is to be prepared in the next 3 months, and then a review is to be prepared in a year or so. So that is how, and the middle of the Cochrane collaboration logo, you can see the illustrated systematic review that we saw before in the forest plot. That this is the picture of the forest plot, which is in the middle of it. And this is from a very famous 7 randomized controlled trial. So that is all from my side. If you have any questions, we still have 3 minutes to answer. So you can ask. From the examination point of view, I must tell you that you should know that how the systematic review is different from narrative review, how the publication bias, how the funnel plot can be assessed for the publication bias. Then you should know that the main structure of the forest plot, what is there in the left side? Is it the first author, or is it the last author to be mentioned, or the year of the study? What these squares are meant for, black squares, what is the diamond is there? And that is actually tells you line of no effect. What is the line? Where is the line of no effect? So it may be there in your, the picture can be given in your exam, and you may be asked that what is this structure? And you may be asked about the confidence interval, whether it is a long confidence interval or a short confidence interval. Like in this example of the forest plot, this is the longest confidence interval for this study. So you may be asked to pick up the longest or the broadest confidence interval. And similarly, what is meant by overall effect estimate, and then what are the different steps of the systematic review and meta-analyses. Yeah, this is all important, and the level of evidence. So from examination point of view, these are important. So that is all from my side. I hope I have justified with my task of presenting and making you understand about systematic review and meta-analyses, specifically forest plots. Any questions? Okay, Hadil, or if you can send me the recording on my WhatsApp, that will be really fine. Okay, thank you.
Thank you, teacher.
Thank you.